So my story is a little bit different. I actually started as a machine learning researcher and did that for quite some years, working in a lab in Israel, doing solving cybersecurity challenges with machine learning. It was quite fascinating. And then I was hit with a really fascinating project by IBM, and they gave me petabytes of data. So back then, we didn't really have enough frameworks or platform to analyze all this kind of data. We really had Hadoop and a little bit of MapReduce, and Mahout was something that we just started with. I don't know if any of you are familiar with Mahout. Has anyone ever heard about it? Yeah, probably. It's a little bit ancient. And since then, I realized, okay, data engineering in this kind of world, and how do we take machine learning and actually put them in production is quite fascinating. So I moved to a position of what back then was a back-end software developer, which is today we call it data engineering. And I recently joined Microsoft a year ago, and I'm happy to say that this is the right place for me to kind of close the gap and say, okay, how do we do machine learning? How do we do data science? How do we take it to scale? And how do we think about ethical and responsible AI while doing it? So before we're going to jump in, as any of you know about different problems we have about bias in AI? Are you familiar with the stories? Because I don't want to bombard you with a lot of crazy stories. I'll just give you one. In Israel in 2017, some years ago, someone from the Palestinian region published a post saying, "Good morning." It was a post in Arabic, and behind him there was a bulldozer standing at the back. So a picture of him, bulldozer, and good morning seems rational. But the thing is, Facebook language translator translated to Allahu Akbar and let's go kill them, something like that. You can only imagine what happens in Israel when someone sees a picture like that with this kind of phrase on Facebook. Everyone is getting into alarm mode. Everyone is running, everyone is afraid, everyone is hiding. No schools, no one's going to the office, no nothing. And that's all because one algorithm got it wrong translating Arabic words. It had two options, and it took the wrong one. Yeah, so I'm sorry I have to open with that, but that's real life. So here you go, some puppies. And I promise that's the last sad story for today. Okay, so let's start with the beginning. What happens when we get the data for the first time? What happens when we face some business challenge and we need to figure it out with data? So first of all, we look at it. We try to understand what it means. Oh, and down there, there's a live captioning. It's a little bit tricky. It's still rendering, but you'll see that it catches different words, and there's also a delay, so apologize for that. Okay. So we'll look at it. We're trying to figure out what it means. And then we enter something called the machine learning process, the machine learning life cycle. Is someone here already familiar with the machine learning life cycle? Already doing it in the day-to-day, in their job, at the office? Cool. So how it looks like. First, we need to gather the data. We need to get all the data that we need in order to solve the problem. The second phase will be the feature extraction. We need to understand what features we need to use in order to feed into our algorithms. We need to clean, we need to normalize the data. There's a whole process around it. Then we need to select the algorithms. Machine learning is statistical based, but then again, there's a lot of different algorithms we can pick from, according to our business use cases, according to the challenge we want to figure out. So we need to select the algorithms. And we also need to evaluate the model. So we need to understand how we're evaluating the model, what kind of different criteria we're going to run with. And then we need to do some data or insight visualization. But that's just not the first thing we're going to do, because we're actually going to do it in repeat until we get a good results, until we get results that we're happy with. All right, yay, we got the result, we have it. Everything works well. You know, we try the Kaggle challenges. Someone here is doing Kaggles once in a while in the university, college. Okay, so Kaggle has a really good challenges for data engineers who want to start and want to understand different features. Definitely, if you're not doing it yet, definitely go there and try it out. It's a great place to learn new things, and it's a great place to learn new algorithms and new challenges. But the thing is, the data there is kind of already cleaned up, mashed up, like already ready for us to kind of use. So that's great when you're doing project for your university. But the thing is, you hit real life, and then it doesn't work. But you had a goal. You want to have high accuracy. And this thing in real life just, doesn't make it. Your boss is going to be mad. Your team lead is going to be mad. You can't make a product out of it because you aim for high accuracy. That's not good enough. So what can you do? You can automate all the process because you already understand you will probably need to run it a few hundred times in order to get a good result. And how do? You do it using pipelines. But just a second, what are pipelines? What does that mean? So pipelines are mostly a sequential task that we can do one after the other, something that we can automate, and we can change different stuff along the way, but we just need to press start and it's going to run again and again. We might change a little bit, we might tweak a little bit our machine learning features there, we might tweak a little bit of the different features that we extract out of the data, but the thing is, the whole process should be as automated as we can. So this is a simple architecture of how you do machine learning pipelines on big data at scale. So on the left, you have some data that you want to get into the system. And it's different kinds of data because we're doing with big data. It can be structured, unstructured, comes from different resources, maybe JSON, maybe CSV file, maybe Parquet, maybe text, who knows, maybe binary. A lot of different kind of files that we can get into the system. And later on, we need to ingest it somehow. So we can use Event Hub or Kafka or different things. And what it gives us, it actually gives us a distributed queue. And with a distributed queue, we make sure we're not losing any of the data, and we're actually going to process each and every one of them. Later on, we would like to put it into some storage. And after that, we would like to actually prep and train our machine learning algorithm. And one of the ways to do it is using Apache Spark. And one of the managed systems we have on the cloud for Apache Spark is Azure DataBricks. Are any of you familiar with Azure DataBricks already? Cool. Are you working with Spark? Someone here works with Spark? Cool. Spark ML? Awesome. So Spark gives us a lot of things that we can work with. And the Databricks is the managed service of Apache Spark that you can actually just go click, create a workshop, and start running with your notebooks. And later on, you can connect everything to something called Azure Machine Learning. You can do different experience, you can track everything you do there, and basically it gives us the whole nice pipeline of how we can do the same experiments again and again, just tweaking a little bit some of the things. So let's see a little bit how it looks. So here we're going to define something called MLflow. And MLflow, it's also something that comes from the Databricks libraries. So MLflow gives us an environment to manage our experiments. So we can actually track everything and put it into some file that we can save it later. Here I'm going to call it some pipeline experience. You can see that an experience name. I'm going to create the client of MLflow, and I'm going to start doing some experience with it. I have some run variable that I'm defining there, and it's actually starting running in the background. Later on, I would like to configure the machine learning pipeline stages. So let's say I'm doing some simple work over text. So I need a tokenizer, some hashing function that I want to use, and some regression that I'm going to use, some linear regression function that I'm going to use. So I'm defining my tokenizer. You can see it at the beginning. Later, the hashing functions, and later the regressions, the linear regressions that I want to work. Now I have all those three instances ready. One quick thing you should notice, that I'm making sure that the input of the output of each and every one of them works together. So if the tokenizer has an input of text, I need to make sure that my data that goes there will have the field of text. Same for the output column. If I'm using, for the tokenizer, the output column name is words, I need to make sure that if I'm going to use the hashing after that, the input column for the hashing should have the same name as the output column. So this is where I'm using the tokenizer.getOutputColumn name. It helps me make it more consistent. And later on, I'm just putting it all together. Apache Spark gives us a really nice library. It's not new, but not a lot of people knows about it. It helps us put everything together in one array. And why do we put it in one array? Because it's sequential. We know our pipelines should happen one after the other in a sequential manner. So we set the stages. We said, OK, we're going to start with tokenizer, hashing, and then the linear regression. So we can have the model, and we're going to call fit. And fit going to gives us the actual model that we can use later. We can save it, we can write it to files, and later on we can load it if we need. So let's say I'm in data science, I'm working with some data engineers. I can create my model, and then I can save it into a file, and the data engineer can take it from there, load it into their system, and actually start running it. Or if I'm working with people that tests my code, it's the same. So if I'm working with the QA, they can take it from there and test it again and again and again as much as we need. So this is just an example of how I can load it back, the last line there. So the same model, loading it from the file. OK, let's create some mock tests. So this is just a data frame, Spark data frame that I'm creating. Yeah, we don't need this one. And then we take the model, and we call it transform. And transform actually works on the data that I give it. I'm saying, OK, take this data and give me the output. And this is going to print the prediction that we have there. So I can actually take this code, put it in production, give it the right model that it needs, and then it's going to give me the prediction that I need in real life. Close and save, just to make sure I'm closing my run under the ML flow. So it looks nice, it looks easy, but life is a little bit more challenging than that. Data engineer and data science have different expectations. Big data projects are very different than Kaggle competitions. And even minor tasks there require Python and Scala and all this kind of skills that not everyone has. So I don't know if you ever had the experience of sitting in a room with data engineering and data science and DevOps. No one goes happy after those conversations, ever, really. Yeah, so this is one of the challenges we face. So then we want to put everything into a bigger context. I mean, we're not finishing and just creating the machine learning algorithm themselves. We want to have it actually running in production. So this is where we need to be able to serve that model. And serving that model, we can do it in different ways. We need to store it in some place, some storage, and then we need to have apps at the end that are actually going to make sure it's going to land into our clients. Or we want to connect it to some place where people can visualize the output and visualize the insights. So some of the ways to do it is using Power BI, which is a great visualization tool. All right. We achieved high accuracy. We're great. Our team leads loves us. We get a high bonus. Everyone is happy. But wait a second. What is the cost? What is the cost of high accuracy? False positive. And I'm sorry, that's true. I said I'm not going to make you sad, but yeah, high accuracy, sometimes we pay with false positives. And false positives mean we classify wrong. And what does it mean, classifying wrong, when we're dealing with humans? When we're dealing with humans, classifying wrong sometimes means sending people to jail. Sometimes mean people are not gonna be able to apply for a specific job. Sometimes it means these people are gonna live under danger or stress for the rest of their lives, just because we classify them wrong. So I'm sorry, here you go, puppy. Let's update our goals. Let's rethink about how we do it. So we need to know our algorithms need to be lawful, meaning respecting all applicable laws and regulations. It needs to be ethical, respecting all ethical principles and values. It needs to be robust from both technical perspective, so we can actually take it and work with it. So we have new goals. It's not only accuracy. It's not only to get the best accurate model. We actually have more things we need to think about, and we need to work with it. But why is that a challenge? It's a challenge because machine learning is a black box. We get some data, we put it into the system, we train the model, and we get the model the output. And later on, we do some prediction. We do some testing. We take the data, we feed it into the model, and we get the prediction back. It works as a black box. Most of the time, we don't really understand how it works underneath. And this is one of our biggest challenges. So let's say we take this kind of architecture that we had before, and we think about it. What can we do with it? What can we do different? First, we need to check and transform the data better. We need to look for biases. We need to understand what exists there. Second, we need to visualize the model. We need a way to understand, first of all, how our data is distributed, and then how we're going to visualize the model better in order to create better models. So that takes a little bit of the automation, but it's going to give us a great value. And we're going to do it using something called explainers, I'm going to look at soon. But first things first. Is anyone here knows how Microsoft supports responsible AI? So we do multiple things, and that's only a short list. First of all, we provide you with online free high-quality courses that you can take and do from everywhere you want, and there's the link right there. Second of all, we invested $1 billion in OpenAI. OpenAI aims to create a friendly and ethical AI. So Microsoft said, OK, you're going to put money on the table. Here you go. Third thing is we have $150 million grants for groups and students and everyone who wants to do AI for good. So if you're doing something like that, and budget is a thing, check it out. Fourth thing is, we invest in open source. So we created some open source tools for you, so you can actually take your model and explain it, and explore it, and look at it, and see it, and understand what it's actually going to do and what it's actually going to mean. And we call it machine learning interpretability. So this is the library we have, and it's split into 3 sections. We're going to look at tabular data, text data, and image data. Tabular data deals with all the machine learning trees and different things around it, and gives us a lot of features to explore those kind of data. Text data helps us explore texts to make sure we're getting the right algorithms if we're doing NLP and all this kind of works. Helps us make sure we're exploring, we understand the relationship between different words, we understand we're taking bias out of our algorithms. And then we have image data as how we actually classify different images. It can be around face recognition, it can be around all this kind of stuff. So here you go, a new set of tools for you to take and start running with your models in your day-to-day, in the university, on any project that you do, to start to get a hint of what it means, how is the machine learning works behind the scenes, so take away a little bit the sense of a black box. And how do we do it? This is kind of a short screenshot of how do you do it with Scikitlearn. Has any of you here already tried different Scikitlearn? Cool. So this is kind of a short explanation about how you can do it. And on the bottom, you can see how you can import the importer. Of course, you need to install it, and there's a lot of adjustment, and you need to work with Python 3 and all this kind of stuff. But once you have it running, you can start using it. And we're actually going to be downstairs. We have a booth. So if you want to try and you want to make it work on your machines, come say hi. We'll help you set it up. But what it gives you something called explainer. And the explainer helps you visualize your data better it shows you how the data distributed, what happens, and what the relationship between the different features. So you can start realize and understand if you need more features, you don't need them, are those features biased? The thing is, it's not going to tell you if it's biased or not, it's up to you. So you still need to work with data experts, with domain experts, with business analysts to better understand. But here you have a set of tools, more tools to make sure you're creating a responsible AI. And this is just one of the things that you can get out of it. So it can actually show you and visualize for you the data in different areas. So it takes the features.
How do you get to this view?
From visualization.
It's in the Azure ML interface?
It's part of the Azure ML Studio. I'm not going to talk about it now because it's a whole topic. But you should come downstairs to the booth and we'll figure it out, we'll make it work for you. Okay? So here's a visualization that can help us understand a little bit more how it works and how we work with it. So we can understand the relationship in the data, the different kinds of features that we're working at. Maybe some features are not relevant for us. Maybe we want to bring more features in. So it kind of helps us a little bit to start to work with what we have. And this is for you. This is the library, so if you want to take pictures and try it yourself, go for it. This is a machine learning interpretability tool, and there's a lot of explanations, tutorials, step by step, how you set it up on different machines, how you set it up locally, how you set it up remotely. If you work at the cloud, you can also work with it in the cloud. It's open source, so you can work with it anywhere you want, based on Scikitlearn. It's also work with Apache Spark data frames, if you're curious and want to do Spark ML with Apache Spark and work with that. Basically everything that implements or if you have your own models, you need to implement predict and predict populations, and it's going to give you, it's going to work for you. But this is not it. We also have something called Azure Cognitive Services. And Azure Cognitive Services, actually it's a built-in API for AI. So you don't need to create your own models. And it has different areas that you can work with there. So it has face recognition. You basically give it the picture, and it will give you the classification. Text and different LNP. So if you're doing sentiment analysis and all this kind of stuff, you can work with it right out of the box. All the other stuff that you're probably going to need and probably going to use, so you don't have to create your own models. And what we do behind the scene, we do a lot of work to make sure it's going to be responsible enough for you to start using it. It's not perfect. Nothing is. There's still a lot of different false alarm and stuff. But Microsoft is putting a lot of effort into making sure this library is going to work the right way without biases as much as we can. So if you're looking from some API out of the box to start doing and running machine learning AI, and you don't want to deal with the heavy hassles of making sure it's not biased, making sure it works well at scale, and all this kind of stuff, you can use Azure Cognitive Services. Cool. Let's look how it looks from Databricks. So this is Databricks. If you're not familiar with that, this is Azure DataBricks. And I already set it up for you, so all I need to do is to launch the desktop itself. And this is how it looks. You can also run it offline if you want on your local machines as well. Here you have all these different things that you can start running with it without looking for it here on the side. You can look at recent different things that I tried and play with, and also go to the documentation. You can write code in Python, R, Scala, SQL, all this kind of stuff. You have the Databricks guide, really helpful, and also importing data. So if you're using your own data and when you want to start importing it, you can use it from here. I think the first thing you want to do when you're using Databricks is actually create the clusters themselves. So all the way back down here, you see there's clusters, and here you can create your own cluster. But I already created a few clusters for us, so we have this pipeline demos and stuff, and you can see I'm using different VMs. When you create the cluster, it asks you for the specific runtime that you want to work with. So I'm using the 6.0, the machine learning runtime, just because I'm doing a lot of machine learning and I want to be optimized for me. And it's also bringing me a lot of different Python libraries and all this kind of libraries that I won't need to think about. So it set up all the variables behind the scenes. But you can do multiple stuff with it. You don't have to pick this one. Under data, it's going to show me the different data that we have. Or I can add more here. Under here, I can add more data if I want, some files, other data sources, or whatever I want to work with. If you're familiar with Spark, you know that Sparks run jobs. So here you can create your own jobs or add them. If you want to add a jar or stuff like that, you can create them and schedule them to run at the time that you want. It also gives us something called Workspace, where we can actually go and dive into our different notebooks and run them from there. So you can see we have different ones. Then we're going to look at this one. So actually here we're going to collect some tweets, just because it's fun. Hopefully the internet's working well. Looks good. So we define, we first of all need to define the connection string because we want to connect to event hubs, and event hubs implements Kafka APIs. So if you're familiar with Kafka, you know there's a producer and consumer. So we're just going to set this one, and here you can see it waits to run. I'm going to take it one at a time. Oops, okay, I'm going to stop it and I'm going to run it one by one just so it will be easier for us. Cool. So I'll start with this one. All right, so we created a connection. Let's connect to get a Twitter instance, so we can actually start and query Twitter to get tweets. Cool. Now we're going to connect Event Hub and Twitter data source, querying hashtag data. So you can actually see there's some events, some tweets coming up. Some people have data meetings, data management solutions. Some other data stuff. Big data, cool. And now we want to read the streams. So let's turn this off. Let this run. And we're actually going to get something in binary, and this is how it works with Apache Kafka. It saves it in binary, and that's something that we can't really read. So you can see it here, the whole body is in binaries. Okay. So with Spark, it's pretty easy to transform the data. So that's the first stage that we want to take. We want to transform the data. And how would we transform it? We take the incoming string and we just change it. We're casting it over with the columns. So this is how we do it with the Apache Spark API. With column, give it the name, what the field that I'm reading it from, and what am I doing to it. So I'm casting this one. Okay, so now I can actually look at the text. Cool. All right, so I get the tweets, data, something, something data. Cool. But this is fine, but we said we want to analyze those tweets, right? So we said we're going to use some cognitive services. Yes, I cancel that. So in order to use cognitive services, first we need to configure some case classes to start running it with. So this is an example of how we can configure the case classes for sentiment analysis. These are basically data classes that will help us hold the variable so we can use it later. So this is how it looks like. And then we create something called the sentiment detector. It's basically wrapping some JSON and prettifying it so it will be easier for us to work with it later. You can see here it takes the request, encoded the text, and do other manipulation on it. And then how we connect everything together, we use UDF. UDF in Spark is a user-defined functions and actually enable us to do different functionality over the data frames that we work with. So here's how we connect everything together. We're actually going to call the cognitive services and the sentiment analysis from our UDFs. So to sentiment and UDF, and basically this is the one we're going to use. And how we put everything together? This is how we do it. We're taking the incoming stream that's already live. We're filtering, not null, because we don't want to have null in our data. Null doesn't mean anything to us. We're casting the body as string, because we saw it already we get it at binary, so we're casting it to string. We call it content. And then we add this column saying sentiment. And here inside, we're calling the function sentiment. That actually, it's a UDF functions wrapping our cognitive service call. Yeah, and at the end, this is what we're going to get. We're going to get the data frame with a new column saying, this is the input that we got, this is the sentiment analysis, and this is how you make it work with cognitive services. All right. Yeah. So going back, if you want to decide and use your own machine learning algorithms and create your own machine learning algorithms, that's great. Make sure you're using explainers, make sure you understand the data, make sure you're creating a responsible AI. Because at the end of the day, our algorithms and the product that we're going to create will only be good as the data we're putting into the system. So this is something you should really think about when you do that. Thank you so much. Here's a little bit of links for you to start trying and playing with different things. There's still a lot of work to be done in the area of responsible AI, and explainers and creating different tools and open source is just the tip of the iceberg. It's just the beginning until we can actually make it into something that is automated and we can, plug and play. Definitely be aware if you're creating machine learning algorithms. Be aware of the different biases. Be aware that you're dealing with humans' lives, and it makes a lot of difference than, just classifying flowers. So hopefully you learn new stuff, and thank you.